Assalamualaikum warahmatullahi wabarakatuh. My name is Amias Dami Muhammad Zamri. My matrix number is A24B3366. Today, I'm going to explain a key concept in geology and engineering. Why building shakes during an earthquake and why some shakes much more than others. It all comes down to vibration. The source of earthquake. To understand why we feel shaking, we need to know where the energy comes from. Deep underground, Earth's crust is made of giant pieces, like a broken shell called tectonic plates. These plates are constantly, slowly pushing and grinding each other. Sometimes the rough edges gets locked along a fault line. Stress builds up and builds up until finally the rock suddenly breaks and slips. That moment of a sudden slip is the earthquake, and it releases a massive burst of energy that travels through the ground in waves like ripple in a pond. These ripples are called seismic waves, and they are the actual vibration that travels from the fault to your house, causing the ground to shake back and forth. The most important things to remember is that not all ground is the same. The type of rocks and soil directly under a building has a huge influence on how bad the shaking is. This is known as a side effect. Rock. When seismic waves travel through hard, dense rock like granite, the energy moves quickly but with a smaller wave size. The shaking is generally less intense. For soft soil, when those waves hit a layer of soft soil like loose sand, mud or deep river sediments, it is like the energy is suddenly hitting a jello. The waves slow down, but their size much more. Amplitudes gets much and bigger. This is called amplification. Think of a small wave hitting a beach and growing taller right before it breaks. Soft soil makes the shaking stronger and longer. The danger multiplier, the resonance. Now let's combine the soft soil shaking with your building. This brings us to the most dangerous concept, resonance. Every building has a natural sway rhythm or frequency. It likes to move at the ground, especially soft soil. Also has a rhythm dictated by the seismic waves. If the soft ground shaking rhythm happens to match the building natural sway rhythm, the shaking gets drastically amplified. It is like a pushing swing at the just right time. The swing goes higher and higher with a minimal effort. This resonance causes the most severe damage, which is why building in a soft soil basin often fare worse than identical building built on a solid bedrock.
Assalamualaikum, my name is Muhammad Faris Naufal bin Muhammad Soha. Nama matrik E25A3697. Today, I'm going to talk about vibration. Vibration is the related movement or shaking of an object. During an earthquake, vibration occurs because of the movement of tectonic plates beneath the earth crust. When these plates suddenly shift, a large amount of energy is released in the form of seismic wave. This wave travel through different types of rock and soil, causing the ground and everything built on it. And second, how is it connected to geology? This is when geology is very important. Geology helps us understand the composition of the earth. Today I'm going to show you, this is my schedule, types of rock and their effect on the vibration strength. I don't know you can see or not, but I will show you. Okay, this is a type of rock. First, we have a hard rock like granite and basalt. The effect on vibration, weaker vibration. The explanation is hard, compact rock transfer energy quickly and do not shake easily. Second, we have soft soil like sand, clay and mud. Effect on vibration, stronger vibration. The explanation is energy is a trap and reflected within the soft layer, increasing the vibration amplitude. And third, we have sedimentary rock like sandstone and shale. Effect on vibration, moderate to strong vibration. Explanation is sedimentary layer can act like cushion, slowing and amplifying the seismic wave. Okay, and we go through the how this knowledge is applied in the real world. For example, geologists and engineering work together to study the ground before construction begins. They perform geological site investigation to identify what types of rock or soil lies beneath the surface. Based on the data, engineering design building with a special foundation that can absorb or reduce vibration. For example, flexible base isolators and damping system. Like in Japan and California, these techniques are used to build skyscrapers that can sway safely during earthquake instead of collapsing. Second example is geology also map earthquake-prone zone using vibration data. This map help city planners decide where it is safe to build hospital, school and houses. Areas with a soft soil or active fault lines are often restricted for high-rise construction to minimize risk. And also geologists can use vibration sensor called seismometers to detect ground motion and predict the strength of future earthquake. This real-time vibration data is used in early warning system, which can alert people seconds before the shaking reaches the surface, saving countless lives. Vibration and geology are strongly connected, and geology helps us understand how seismic waves move through the earth, while engineering applies that knowledge to create safe building and infrastructure. By studying vibration in relation to geological condition, we can predict earthquake behavior, plan safe facility, and even locate underground resources. This shows that geology is not just about studying rock, but it's about using earth knowledge to protect life, build a safer societies, and ensure a sustainable future. That's for me. Thank you.
Assalamualaikum and hi. My name is Muhammad Akil Azim bin Azhar. My metric number is E25B3635, and today I would like to talk about an earthquake that caused by vibration and what it has to do with geoscience. An earthquake is not just a shaking of the ground. In the world of geoscience, it is a natural process that reshape and transform the earth crust. When two tectonic plates move and slide past each other along the fault zone, the energy stored inside the earth is suddenly released in the form of seismic wave. The vibration we feel as an earthquake. But deep beneath the surface, something even more fascinating is happening. The intense pressure and friction along the fault zone cause the surrounding rock to change their structure. Some rock cracks, other crumble into fine grains, some transform completely under extreme stress. In geoscience, this transformation is known as a dynamic metamorphism, a process where existing rock are altered by mechanical pressure without being significant heat. From this process, new type of metamorphic rocks are formed, such as mylonite, catellixite, and pseudocatellite. Mylonite form when rocks are sheared repeatedly under great pressure, producing thin layer texture. Catellixite result from rock being mechanically crushed during sudden movement along the fault. And the most unique of all, pseudocatellite is a dark glassy rock that forms when frictional heat melts part of the rock during intense fault movements. In addition, there is a fault breccia, a rock made up of a large broken fragment produced when the earth crust fractures violently. Although it does not form through metamorphism, fault breccia plays an important role in geoscience because it is preserved evidence of ancient earthquake. It's helping scientists to study the history of seismic wave in a region. Through the study of this rock, geoscientists can trace how the earth crust move, interact, and evolve over millions of years. Each layer of rock in a fault zone tells a story of pressure, energy, and time, showing that earthquakes are not merely a natural disaster, but a vital part of the Earth's continuous and dynamic cycle of change. That's all from me. Thank you.